Alright, so this is part 2, and we're going to start right away with question 7, where it says entrained air is drier than the air within the cloud. So this is entrained air, they mean the air around the cloud itself. So this is the stagnant environmental lapse rate air, using keywords that we've used. Consider phase change of water. How could this lead to further cooling? So within the cloud itself, I'm having phase change, I'm having latent heat happen. This is going back to question 5 above, but as well as what we know about cloud process. How would the phase change and the fact that the air is continuing to rise create further cooling? Well, as air rises, it cools, but it is going to cool at a slower rate, and therefore it's not cooling off as fast as the environmental lapse rate air. So it's the answer to question 7. However you can say that, that's what we're talking about. The environmental lapse rate air is still colder than the cloud, and the act of phase change, the act of water within the cloud changing from a gas to a liquid or a solid, is slowing its cooling, keeping it warmer than the environmental lapse rate air, and therefore it will continue to rise. Question 8, how could the updraft and downdraft contribute to the cloud droplet ice crystal growth? Updraft holds the water aloft, the downdraft pulls it down rapidly so it doesn't have time to evaporate. This is why only in thunderstorm clouds, only in these standard thunderstorms, right? This is my symbol for thunderstorm clouds, will I get the ability to grow things like hail. It'll only happen there because the updraft holds the water droplets up and the downdraft pulls them down so fast they don't have time to melt. Alright, so moving forward, we're going to talk about severe thunderstorms. So now we're talking about things that produce either high winds, have lightning, or have really big hail. So that's the key. This right here is the key to what is a severe thunderstorm, which means it's going to have all the stages in the previous part where we made a cumulonimbus thunderstorm cloud, but now we're making them have more than that. They're going to definitely have some lightning, definitely have really high winds, or definitely have hail. And one of the key types of thunderstorm clouds that's really an exclusive U.S. caused by the maritime tropical air mass is the fact that we can get this line of thunderstorms along the cold front. So remember, my cold front comes in, cold front, and it creates this bubble wedge. This is just the warm air, right? This is the warm air that's stagnant, and it's going to shove this air up and over, and when it does that, it makes these vertical clouds. Well, these fronts mean that I can create this whole line of thunderstorm clouds, and we call this line, this frontal line of cold clouds, we call them squall lines. Along this standard stream of air. And I've kind of highlighted the little bit about squall lines and how they occur along these frontal processes. So explain downdraft triggering the development of new thunderstorm cells. This should feel kind of self-explanatory. If I have a downdraft pouring out of my cloud, that air is going to be warmer than the environmental lapse rate air, so when it gets down to Earth and it loses its speed, it's still going to be warmer, and therefore it will have advection occur, right? And it will rise up. So these downdrafts basically are still warmer than the air and the environmental lapse rate, and when they run out of wind speed, so that they're no longer flowing vertically, they will begin to rise again. So advection is occurring. So that's the answer to question 9. Question 10, how do air mass conditions ahead of a squall line support the development of new cells? Well, if I have a big old air mass and it's moving along this standard line that would be kind of down here, right? So I have my little low pressure cold wind occurring here in my icicles. Then I'm going to have a whole bunch of thunderstorm clouds, and each one will have a downdraft, which will then have advection occur, and rise. Downdraft, advection occur, and rise. Downdraft, advection occur. So these squall lines just make new cells constantly, right in front of wherever the downdraft is happening. And so squall lines breed more thunderstorm squall lines.